Welcome everybody to the Resilient Schools and Disaster Risk Reduction Education MOOC. And you have finished Module 1 last week. Now this week we're going to be actually going to the introduction to the comprehensive school safety framework. So we're going to have here 3 modules. The first module will be divided in 2 parts. The part 1 that we're going to see in this video, we're going to be shaping the school safety major related concepts, risk and hazards. And we're going to be discussing how the hazards has been included in a different classification by clusters. Then in the second part, in the next video, we're going to be discussing the exposure concept, the vulnerabilities, physical and social capacities, and about the concept of resilience. We're going to then go to the next video where we're going to actually introduce the comprehensive school safety framework. So we're going to overview the foundations of the what we call the CSSF. And then we're going to be briefly discussing each of the 3 pillars of the CSF. We're going to finish this video or this module with the last video that will be about school safety and systemic risk. So welcome back, and welcome back to this first module of the part 2 of this MOOC. So as I say, we're going to be discussing about shaping school safety major related concepts, notably on disaster risk reduction, which are very important for us. And I want to inform you that all of this content has been adopted by the United Nations General Assembly. So it was established by what we call the open-ended working group on targets and indicators that also worked on the definition of this specific context. So this has been an agreeable worldwide definitions that were working by different specialists coming from all parts of the world. And they arrive on a consensus on the different elements of what is risk, for instance. So as we have introduced the concept of risk in the previous module, risk normally is understood as the combination of a hazard for the exposure for the vulnerabilities. And those vulnerabilities can be reduced or can be increased depending on the capacities that every single individual could have, or every community or a specific system. So some authors understand the risk only as the combination of hazard and vulnerabilities, because they understand that within the vulnerabilities, exposure and capacities are already included. But how it has been defined, the concept of risk? So it has been defined as the potential loss of life. So if there are people that died in a specific event, or that are injured on that specific event, or are destroyed or damaged assets, which could occur to a specific system, a society, or a community in a specific period of time. It's very important to determine here the periodicity and the time of these things. Normally, this is determined by probabilistically as a function of, as I mentioned, hazard, exposure, vulnerability, and capacities. As this is what we normally understand as the inherent risk. This risk that that is part of our own systems, or our own societies, our own communities, etc., etc. So these kinds of risks, notably, they have different kind of interpretations. So there are risks that could be acceptable. That means that kind of the extent of which disaster risk is acceptable or tolerable by the societies, and that will depend on the social, economic, political, cultural, technical, and environmental conditions. So we live with risk. This is something that we need to understand. Risk, we cannot avoid risk. It's part of our existence. Risk is part of it. But there are risks that are acceptable. So, when we go out of our home, we know that maybe we are facing some risk because maybe there is a car. If we don't put attention, we are facing risk every day in every single moment of our life. And there is a broadly acceptable risk, there is a tolerable risk, and there is some kind of intolerable risk. Some kind of risk that we really need to start putting measures, because we don't want to arrive to a moment on which when we can have the potential of death or injury or damage or destroyed of a specific assets. Then, what is the residual risk? So normally we can determine that the residual risk is this risk that remain even when effective disaster risk reduction measures are in place. for which emergency response and recovery capacities must be maintained. And the presence of residual risk implies a continuity need to develop and support effective capacities for emergency services, preparedness, response, and recovery, together with socioeconomic policies such as safety nets, risk transfer mechanisms as part of a holistic approach. This will include, for instance, insurance that are very good in order to transfer some part of the risk that we need, that we cannot measure. So this is a financial mechanism that we can have here. So we say that normally in our societies we have this kind of risk that we have to live with it, that is inherent to us, and that inherent risk is that one that we have normally with the absence of any kind of controls, of mitigation, of prevention. Then when we apply some controls in order to reduce those risks in terms of creating more mitigation activities or prevention activities, or playing in the other part of the equation by increasing the capacities or reducing vulnerabilities, we are also putting some controls. But even that, when we do the sum of the inherent risk plus the controls, and this sum we put like 1 minus that, we're going to have that residual risk. So that risk that remains even when we put some controls and we try to reduce it as much as possible. So we need to start living with risk, but we need to try to reduce it as much as possible. So, and there are some categories of risk that are very important that we take into consideration. The first one is about the extensive risk. And when we are talking about the extensive risk, we are talking about that specific risk that is produced by low severity but high frequency hazardous events and disasters that mainly, but not exclusively, are associated with highly localized hazards. It's very important that we understand this concept of extensive risk, because although the losses that these small and recurring events produce only 14% of the total of mortality, but it represents more than 42% of the total economic losses of low and middle income countries. Normally, extensive risk, and this is very important, is exacerbated by poverty, urbanization, and environmental degradation. There are some underlying risk factors that we're going to see in the last video, where we're going to be talking about the systemic risk. So a good example of extensive risk, droughts, for instance. Droughts have really special repercussions, because you don't see that it's something that arrives in a moment, but is prolonged in the time, but has serious issues because they can disrupt the societies as we see. For instance, in the last special report produced by the Global Assessment Report of UNDRR, it's focused on drought, because they have been realizing that drought doesn't have any issue if you are coming from a poor country or from a rich country. We have seen droughts everywhere in the world. The most recent, for instance, in California, where we are having really issues there with drought. And these droughts are causing that they are in the areas where we have droughts, there are a lot of rising school dropouts rates. And there is also a negative impact on girls and school attendance. So this is one example of extensive risk. So not on the hazard drought, but all the elements that generate that risk, like the exposure to droughts and the high vulnerabilities and the low of capacity that we can have in this specific hazard. As you will see, and this is something that we will mention later on in the systemic risk model, when we talk about droughts, the implications and the impacts of droughts has many cascading effects. They have cascading effects because increased workloads, because has effects on employment and financial constants, depressing economies, decline in agricultural production, crop failure, and livestock losses, which can produce also issues of nutrition, of bad nutrition, decreasing the ability of access to food, dietary changes, etc., etc. So as you can see, all of these specific elements that a specific hazard can produce has some cascaded effects that at the end we're going to start analyzing when we see this with the approach of the systemic risk. in parallel to the extensive risk, we have intensive risk. And when we are discussing about intensive risk, we are talking about the risk of high severity, mid to low frequency disasters, mainly associated with major hazards. And here, for instance, we talk about the characteristics, for instance, of large cities or densely populated areas that are not only exposed to intensive hazards such as strong earthquakes or active volcanoes or heavy floods or tsunamis or major storms, but also have high levels of vulnerabilities to these specific hazards. So, for instance, when we have poor construction in a specific cities, so that creates, that the characteristics of this specific society or community can be very, very increased by the effects of a specific hazard that has major impacts like high severity, but that are not very frequent, like tsunamis or earthquakes that are good examples of this. And what do we want, when we are talking about risk, what is the element that we want? What we want is really to try to apply it as much as possible, all the possible strategies, policies that will allow us to prevent the new disaster risk that can be caused, to reduce that existing disaster risk that we have, and to manage the residual risk that we introduced before. And this with the main purpose to contribute to the strengthening of resilience and the reduction of disaster losses, including the death of people and injuries. And this disaster risk management that we will apply through actions, policies, and strategies can be distinguished between three different kinds of disaster risk management: a prospective disaster risk management, a corrective disaster risk management, and a compensatory disaster risk management that is also called residual risk management. So, and as the slide is presented, all of this is very linked with governance and about what are the strategies that we're going to implement in order to really reduce effectively risk in our societies. So, concerning prospective disaster risk management, is all of these activities that are addressed and seek to avoid the development of new or increased disaster risk that we have, or increased disaster risk, sorry. They focus on addressing disaster risks that may develop in future if disaster risk reduction policies are not put in place. A good example of this is the land use planning. So this is a good activity, a good strategy that aims to reduce future risks if we don't know how to organize well our cities, and if we allow, for instance, construction in areas that are highly exposed to different kind of hazards, like coastal hazards, like landslides, etc., etc. Another example of this is the management of urban water. So how we can start preventing and using good urban water in order to avoid scarcity and all the risks that are produced by the different elements related to water-related disasters. Another kind of disaster risk management strategy is what we call the corrective disaster risk management. And it's talking about all those activities that seek to remove or reduce disaster risks which are already present and which need to be managed and reduced now. One of these examples that I was mentioned before was poor construction, physical vulnerabilities. So we can have some corrective measures like retrofitting those buildings, assessing and retrofitting those buildings in order for them that they can increase their capacities to resist any kind of hazard that can affect it, such as earthquakes, such as tsunamis, such as floods, etc., etc. So we are correcting something that we know already that is bad in order to increase the capacities and reduce the vulnerabilities in this sense. And then we have another kind of actions on disaster risk management that are related to compensatory disaster risk management. And those are those activities that strengthen the social and economic resilience of individuals and societies in face of residual risk. So that risk that, as we discussed before, cannot be effectively reduced. It's very difficult to be reduced even when we apply all the controls, disaster risk mitigation activities, prevention activities, and even if we increase all the capacities and reduce all the vulnerabilities, that part of the risk that also will be there. So this compensatory risk management talks about those activities that we're going to put in place in order to manage that part. And what does include? Include, of course, all the activities related to preparedness, to response and recovery activities, so that part of the disaster risk reduction cycle that we saw in the previous module, but also is mixed most of the time with financing instruments like insurance, like national contingency funds, contingency credits, social safety nets, etc., etc. So risk that we can try that even if something affects us, and we can have all the elements in order to increase the capacities to face the negative impacts that the hazardous event produced to us. So, as we say, what is the idea here? Is that we can create disaster risk reduction. Disaster risk reduction is the policy objective of disaster risk management, and it's very important, and this is why we talk about creating resilience school and disaster risk reduction education, because the main target here is that we can manage to reduce as much as possible all that inherent risk by applying all the controls and trying to see how we're going to manage this residual risk. And disaster risk reduction, what it's saying is that preventing new and reducing existing disaster risk and managing residual risk, as I just mentioned, all of which contribute to strengthening resilience and therefore to the achievement of sustainable development goals. As we see it before, this linkage between the adaptation agenda, the sustainable development agenda, and the disaster risk reduction, creating really resilience for the major challenge that our societies are living now, and that has agreed to work together in this 2015-2030 agenda that we have seen. So now I'm going to pass to the other concept that is very important in our equation, that is hazard. So as we say, risk is it's an equation that depends of hazards, vulnerability, and exposures. So hazards has been defined by this group that I mentioned at the beginning, and the definition has been adopted by the General Assembly as a process, phenomenon, or human activity that may cause loss of life, injury, or other health impacts, property damage, social and economic disruption, or environmental degradation. Normally, hazards can be categorized on three specific ways. They can come from naturally, so from those natural processes and phenomena that are related to the evolution of the earth. And here we're going to see, like, for instance, earthquakes. They can be anthropogenic, so that means all these specific hazards that are related to the human activity, to the human action, or they can be of socio-natural origin. So that means all of these hazards that are related to the normal evolution of the planet, but that has been influenced in a way in order to increase their intensity or their frequency by the human activity of our individuals and societies. The biggest example of this, climate change. So hazards has been now categorized in 8 big clusters of hazards. This has been a specific word that scientists all around the world, under the leadership of the International Science Councils and UNDRR, has classified. They have listed all the hazards that are nowadays in our societies. It's a working document, but they have already identified 302 hazards, of which 88 are biological hazards, 60 hydrometeorological, 53 technological, 35 geohazards, or coming from a geological origin, 25 chemical hazards, 24 environmental hazards, 9 extraterrestrial hazards, and 8 societal hazards. I'm going to go now in defining what are all of these classifications. So hazards nowadays, as you can see, and we were mentioned before, we have these hazards that come from natural processes. There are some that are anthropogenic, and another ones that are called socio-natural hazards. So that those hazards that normally intersect between the nature and the human activity. And sometimes we are saying that we are denaturing hazards. For instance, fracking. With fracking, we are creating more seismicity. Before, it was something that it was not even foreseen, that how human activity can create seismicity. Well, an example, with explosions, big explosions, or fracking, we are creating seismicity and the potential of have more intensive earthquake or seismic hazards in that perspective. I will come back to that later. So the first cluster that has been defined by this group is the meteorological and hydrological clusters. Normally, they result from the state and behavior of Earth atmosphere, its interaction with the land and oceans, the weather and climate that it produces, and also as well in the distribution of water resources. If we see meteorological hazards nowadays, they represent 56% of the deaths and 75% of the economic losses are attributed today to weather, climate, and water-related hazards. Some of the most devastating hazards include tropical cyclones, droughts, as I mentioned before as an example of extensive risk, riverine floods, and heat wave, something that we saw, for instance, recently in Canada, where temperatures rise more than 49.6 degrees in regions where we never saw it, and that produced a lot of casualties in that specific country of the world. When we are talking about the geological hazards, so we are talking about those hazards that has geological origin. And they are divided normally into three different categories. Those that come from seismogenic origins or volcanogenic origins, so that are related to the Earth internal geological process that are really at the core of the Earth, at the core of the Earth process, and those shallow geohazards that are more related to the surface or near surface processes, such as landslides, for instance. Extraterrestrial hazards. So extraterrestrial hazards, as you can imagine, are those originated outside the Earth, such as asteroids and meteorite impacts or solar flares. But also there are those that are now being produced, for instance, from those satellites or elements that we are putting in the space, and that can, by entering in the atmosphere, can generate an impact to our society. So this is something to put in our attention as well. Environmental hazards. So environmental hazards are those that arise through degradation of the natural systems and ecosystem services upon which humanity depends. Ecosystem services including air, water, land, biodiversity, and some key earth processes are threatened by environmental degradation, here defined as a loss of utility. And here we have some that are natural, like coastal erosion, but some that are being accelerated by human activity. For instance, pollution, deforestation, contamination of our water resources. Then we have the cluster of chemical hazards. And as you could imagine, chemicals, the use of chemicals has increased dramatically in many sectors, agricultural sector, for instance, industry, transportations. And people is getting exposed to those chemicals either in a natural way or in a human or by human origin activities in the environmental and in the technological domain. This includes, for instance, industrial chemicals, explosion of hazards like the blast, for instance, in Lebanon, pollution, terrorist threats, anthrax, if you remember well, corrosive, flammable, and toxic chemicals pose several types of hazards. And here we can see, for instance, some chemicals contamination that, for instance, has been natural. The arsenic crisis that we saw, for instance, in Bangladesh and in some part of India. So naturally, water was contaminated by the deposition of arsenic that was on the underground water. And the consumption of this water by local populations create that getting exposed to this specific hazard, this specific water that have arsenic, to create some consequences like arseniosis, those health issues that they can have. So we can see that chemicals, sometimes they are not only produced by human activities, but also naturally, as in the arsenic crisis that we see in Bangladesh and India, among other countries. Then we have biological hazard that was very famous recently, notably because of the COVID-19, and they cover a range of hazards of organic origin. It includes pathogenic microorganisms and toxins and bioactive substances that occur naturally or are deliberately or unintentionally released. Bacteria, viruses, parasites, venomous animals, and mosquito-carrying disease-causing agents are also examples of biological hazards. For instance, the dengue, can be one of these specific biological hazards on which one we can have this kind of views. So biological hazards, as I mentioned, they come is an organic origin. But it's very important also to try to see here, for instance, with the COVID, because there are many researchers now that discuss about, the implications that climate change has had on these biological hazards, because we have biologists has identified a number of viruses worldwide, and there are many that hasn't been identified because they are part of biosphere reserve or ecosystems that hasn't been explored at the level of scientists. And those viruses, have been there, for instance, in the jungle for many, many years. With urbanizations, with deforestation, we have been taking or eliminating some of the barriers, natural barriers that we have in these tropical environments that we have before. So our societies are getting closer and closer to those specific viruses on which one we were not supposed to be exposed. So this is something interesting to take into consideration when we are talking about the social nature characteristics of these hazards. Technological hazards. So technological hazards, they arise from the possibility of failure of an existing technology as well as from emerging technologies. The technological hazards involve all transport systems like land, sea, air, can affect the infrastructure that supports these systems as public and private services. The characteristics normally of this technological hazard is the complexity and that they depend on many subsystems. So a failure of one of the elements within this system or these subsystems will have some impacts and can spread through the chain, the cascaded effects that we're going to mention and that we're going to see and that we need to take into consideration when planning for school safety. However, impacts can also occur outside the system that are and that can come there. One big example of technological, Chernobyl, Fukushima. Some technological issues that can be triggered, for instance, like by an outside element, like it was the tsunami for Fukushima, or by inside element, like it was the explosion in Chernobyl. So this is something that we need to take into consideration. So with the technological hazards, we are now finalizing this first part 1 of the module 2.1. Gonna be continue with you now discussing about the other elements like exposure, like vulnerability, capacities, and resilience. So thank you for your attention and see you in the next video.